Okay, this is Project Test 8, video number 2, and we're going to cover problems 11 through 20. Resting heart rates and beats per minute were recorded for 2 samples of people. One sample was from people in the age group of 20 to 30 years, and the other was from people in the age group of 40 years to 50 years. The 5 number summaries are shown in the table below. And just as a reminder, the 5 number summary is the minimum, Q1, which is the lower 25%, the median, Q3, which is the 75th percentile, and then the maximum. These values make up the 5 number summary. The values 60, 62, and 84 were common to both samples. The 3 values are identify outliers with respect to the age group of 20 to 30 years old because they're either 1.5 times the interquartile range greater than the upper quartile or 1.5 times the IQR less than the lower quartile. Using the same method for identifying outliers, which of the 3 are identified as outliers for the age group 40 to 50. So we're only paying attention to the age group of 40 to 50, and we have these values, and we want to know whether or not any of them are outliers for that age group. So once again, our outlier formula for the lower end is X must be less than Q1 minus 1.5 IQR. Now, please remember, IQR is equal to Q3 minus Q1. And our Q3 is 76, and our Q1 is 70. So our IQR in this instance is 6. So let's plug in what we know here. All right, Q1 is 70. 70 minus 1.5 times 6. That's 9, so 70 minus 9. So X must be less than 61. If it's 61, it's not an outlier. It's on the fence. That's not an outlier. But sure enough, 60 is an outlier. So that gets rid of A, and that's also, we know that 60 is an outlier. We don't know about the others. So we need to do the upper, check for an upper outlier. For the upper outlier, it's X has to be greater than Q3 plus 1.5 IQR. Well, Q3 happens to be 76 plus 1.5 times the IQR that we already calculated was 6. So 76 plus 9. So in this case, our IQ, we have to have an X greater than 85. If we have an 85, it's not an outlier. So it turns out our highest value is at 84. It's not an outlier. We already know 62 is not an outlier. So only 60 is our outlier. Only 60 is an outlier. We have an outlier on the lower side because it's lower than 61. We have no values greater than 85. All right, so 11 is B. Moving on to number 12. As part of a demographic study, a college administrator needed to survey a sample of students from the college. From each major offered at the college, the administrator randomly selected 5% of the students with that major to participate in the survey. Which of the following is the best description of the type of sample selected by the administrator? So what we did here is we broke them down by majors. Maybe we have art and business and science and engineering. I don't know. So we have them broken down by business, by groups. Whenever you break them down by groups, which is what we did, it's either going to be a cluster or it's going to be a stratified. So to be a cluster sample, they have to be all mixed together. In this case, they were not all mixed together. We looked at the art and took a random sample within the art. We took a random sample within the business. And so we broke them into strata and selected a random sample within each. So D is this one. All right, so 12 will be D because we broke them into different strata. We broke them down by major and then did a random sample within it. A cluster sample, they would have to have all the majors together, and then we perform a census within one of the clusters. All right, number 13. The graph shows the population distribution for a random variable X with a mean of 85 and a standard deviation of 18. And by the way, when I look at this, I go, you know what? Just as a reminder, stretch to the left. So skewed left. And they're telling me my mean is at 85. And if this is my mean, I know my median is going to be up here somewhere to the right of it. My median is going to be to the right because the mean is less than the median for skewed left. The mean is less than the median. The mean is this way. The median will be up here. Which of the following graphs is the sampling distribution of the sample mean X bar for samples of size 40? Okay, so since n equals 40, which is greater than 30, this is going to be normal by central limit theorem. All right, so we're going to be looking for something that's reasonably normal by central limit theorem. Well, that gets rid of some graphs real quickly. That gets rid of A, and that gets rid of E. But then I have these other mound-shaped graphs, and I have some decisions to make. Well, the mean isn't going to change. The mean needs to be centered at 85. Well, this looks like it's centered at 85. This one is also centered at 85, but we can eliminate D because it's not centered at 85. But now we need to consider the standard deviation. Well, our original standard deviation, the standard deviation of the population was 18. They gave us that. But the standard deviation of X bar equals the standard deviation of the population divided by the square root of n. So that's going to be 18 divided by the square root of 40. 18 divided by the square root of 40. So that means 2.84. And remember, if it's normal, we should have about 3 standard deviations above and 3 standard deviations below. So 85 plus 3 times that says my highest value should be around 93.5. That looks pretty good. Okay, I get over here, the highest value is at 87, that gets rid of that. Let's go ahead and check to make sure we have it low enough. 85 minus 3 standard deviations. And we have, 85 minus the 3 standard deviations. Not sure what I'm doing wrong on the calculator, but I'm doing something wrong. Let's clear this. 85 minus 3 times, there we go. And we end up with about 76.4. So the lowest value should be right around 76, and that's pretty close. All right, so our best answer to this is B. And remember, it's plus or minus 3 standard deviations. The reason we always say that is because 99.7% of our data by empirical rule lies within that interval. There's not very much outside of it. There's some because it goes all the way to negative infinity and all the way to positive infinity, but we should have about plus or minus 3 standard deviations. This is our best choice. Number 14. A biologist studying trees constructed the confidence interval 0.14 to 0.20. And by the way, from that, I end up getting a p hat. I can add those values, 0.14 plus 0.2, and I divide that by 2. It's like, oh, your p hat, the middle value happens to be 0.17. So I have a middle value of 0.17. That's my best estimate. Using the same confidence level, the interval was later revised because the sample proportion had been miscalculated. The correct sample proportion was 0.27. So we thought it was p hat is 0.17, and that was the interval for 0.14 to 0.20. Turns out p hat was really equal to 0.27. Which of the following statements about the revised interval based on the correct sample proportion is true? All right, if all we changed was this, if all we changed was we went from 0.17 to 0.27, remember, as p hat approaches 0.5, the interval gets wider. So as p hat approaches 0.5, the interval gets wider. So this one will have a wider interval because it's closer to 0.5. Because remember, the largest thing that we could possibly have in the numerator is 0.5 times 0.5, which is 0.25. And let's multiply those out. 0.5 times 0.5, and you see you get 0.25. Here would be 0.17 times 0.83, which is only 0.1411. And over here, it would be 0.27 times 0.73, and that's definitely wider than this. So this will give us a wider interval than this one. So the revised interval is narrower, and is narrower. So that gets rid of A and B really quickly. We know that they're incorrect. The revised interval is wider. That looks good than the original interval because the correct sample proportion is farther from 0.5. No, it's closer to 0.5. So this is the wrong reason. The revised interval is wider than the original interval because the correct sample proportion is closer to 0.5. I like that. So 14 happens to be D. Number 15, a research organization reported that 41% of adults who were asked to describe their day responded that they were having a good day rather than a typical day or a bad day. To investigate whether the percent would be different. So basically they're saying, you know what? We're going to accept that P equals 0.41, and we're going to run an alternative. And they say different, so not equal to 0.41. For high school students, 600 high school students were randomly selected. So N equals 600. When asked to describe their day, 245 reported they were having a good day. So X equals 245. So P hat equals 245 over 600. Do the data provide convincing statistical evidence that the proportion of all high school students who respond they were having a good day is different from 0.41? So first off, our formula is the probability that Z, or 2 times the probability that Z, well, let's go with Z equals P hat minus P naught over, I don't want the 2 in front of that, P naught Q naught over N. All right. So that would be a formula, and we plug into that if we were doing an FRQ. But since we're just doing it on multiple choice, we can go straight to the calculator. And we can go stat test, 1 proportion Z test. Our probability, the claim is 0.41. We have 245, N is 600, and we want to make sure we have a not equal. We calculate, and I get a very large p-value. I get a p-value of 0.9338. And it doesn't really matter which alpha I choose. This is definitely greater. So we're going to fail to reject. So if I'm failing to reject the null, I am believing this. So, do the data provide convincing statistical evidence that the proportion of all high school students who respond is different? And the answer is not yes, it's definitely no. No, because the p-value is less than any reasonable. It's because it's greater than any reasonable alpha. All right, so 15 is B. Moving on to 16. The director of a community recreation center conducted a 6-week study to examine the effects of 4 types of exercise. We have strength training, flexibility training, aerobics, and jogging on maximal oxygen consumption. These right here, from the 40 members who participated, the director randomly assigned 10 members to each exercise type. So we basically have this. Not a very good drawing, but strength, flexibility, aerobics, and we have jogging. And this one has 10 members, 10 members, 10 members, and 10 members. And we did this by random assignment. If we did this by random assignment, we have an experiment, okay? The doctor examined the change in maximal oxygen consumption for each member. Which of the following statements is correct description of the feature of the study? The study has replication because there's 4 types of exercise. No, the replication occurs because there are 10 people per exercise. Basically, the 10 people were the subjects or the experimental units. And because we had more than one experimental unit for each treatment, we had replication. So this is false. The study has replication because it was conducted over a 6-week period. No, once again, the replication is the 10 people. The response variable is the type of exercise. No, the type of exercise is the type of exercise is the treatment. So these are the treatments. But our response variable is the oxygen consumption. Oxygen consumption, that's our response variable. The treatments in the study are strength, flexibility. This is true. This looks like this is our answer. The experimental units are the 4 types of exercise. These, once again, are the treatments. The experimental units are the 40 people. So the experimental units are the 40 people. This is false. Our best answer is D. The treatments in the study are strength, flexibility, aerobics, and jogging. And we can also call these the treatments as the explanatory variables. Okay. Sean and Evan are college roommates who have part-time jobs as servers in restaurants. So we have Sean and we have Evan. The distribution of Sean's weekly income is approximately normal with a mean of 225 and a standard deviation of 25. Evan's weekly income is approximately normal with a mean of 240 and a standard deviation of 15. Assuming their weekly incomes are independent of each other, which of the following is closest to the probability that Sean will have a greater income than Evan? All right, so first off, if I subtract these two, I find that the mean of Sean minus Evan equals negative 15. Unfortunately, I can't subtract standard deviations. I'm going to have to square them and then add them. And the reason they told me they were independent is I cannot combine standard deviations at all unless they are independent. Because they're independent, we can combine them, but we have to square them and add them. So when I do that, I have 25 squared plus 15 squared. And I'm going to basically, the standard deviation is the square root of 850. The other thing, they told us that they were normal because they need to be normal so that we can combine the distribution. Well, now that I've combined the distributions, we have our standard deviation equal to the square root of 850. That's the Sean and Evan standard deviation right here. And we have a mean of negative 15. Which of the following is closest to the probability that Sean will have a greater income than Evan? To be greater than Evan, I have got to cross 0. So I am looking for the probability that X is greater than 0. So that's going to be the probability that Z is greater than 0 minus a negative 15 over the square root of 850. So let's go to the calculator because we can do this with a norm CDF at this point. Second vars, normal CDF, lower bound is 0. Notice I shaded all the way to infinity. My mean is negative 15, and my standard deviation is 850 raised to the half power, or the square root of 850. And I end up getting 0.303. Excuse me, I got the sneezes now. So 17 is D. All right, number 18. According to the data from the United States Elections Project, only 36% of eligible voters voted in the 2014 elections. For random samples of size 40, which of the following best describes the sampling distribution of p hat? So first off, we have no idea what the shape is of the distribution of elections, but we have sample size 40. So because we have a sample of size 40, we know that it's going to be normal by central limit theorem. And we can check this out by this. NP, NQ. So 40 times 0.36 is 14.4. That's greater than 10. And we also have 40 times 0.64. So we know that these are both greater than 10. Excuse me, that's 25.6. Both are greater than 10. Therefore, we can use the normal approximation. So this sampling distribution is approximately normal. You can get rid of that. The mean is always going to be the mean. So the mean will be 36. That gets rid of this one. But now we need to be careful about our standard deviation. Well, we're working with proportions. So I'm going to go ahead and write our formula. And we basically have this p hat minus p naught, q naught n. This is my standard deviation. So let's try that out. 0.36 times 0.64 divided by 40. And I'm going to take the square root of that. And I get 0.076. So 18, I end up getting C as my answer. And once again, this part right here is the standard deviation, and here's what I plugged in. 0.36, 1 minus 0.36, which happened to be the 0.64, and my sample size is 40. And I just solved that part right there. Okay, and that gave me the 0.076. So 18 happens to be C. All right, moving on to 19. To investigate whether the consumption of beetroot juice enhances exercise performance, a researcher selected a random sample of 50 student athletes from all the student athletes at a college. All student athletes at a college, that's important. The athletes in the sample were randomly assigned to one of two groups. In one group, 25 were given a daily dose of beetroot juice. In the other group, the remaining athletes were given a daily dose of a placebo. At the end of 6 weeks of the exercise training, the researchers compared the performances of the two groups. Based on the design of the investigation, which of the following is the largest population to which the results can be generalized? All right. So basically, we should be generalizing to student athletes at that college. Not all student athletes, not all people at the college, only student athletes at the college. So the 25 student athletes assigned, no, no. All student athletes at the college, that looks pretty good. All students at the college, no, it has to be athletes. All people who exercise, no. We only checked it at one college and we only checked the student athletes. So 19 is C. Number 20, college researchers wanted to know under what conditions people are more likely to complete and return a survey. As a part of the study, the researchers prepared 3 sets of identical surveys and used 3 methods of delivering and returning the surveys. The methods are described as follows. In class, the surveys were given to students in a class, and students were asked to return completed surveys to their instructor. All right, so we ended up with this. And we ended up with about, well, over 50% returned it. Okay, psychology. Their surveys were given to students participating in a psychology experiment. The students were asked to return completed surveys to a collection box in the hallway of the psychology building. And we look at this and go, you know what? About 50%. This one's more than 50%. Here is about 50%. In the dining hall, the surveys were given to students in the dining hall, and students were asked to return completed surveys to the box outside. And here we're looking at about 30%. So this is greater than 50, equal to 50, and right here, we're about 30%. Okay? Which statement about delivery method and rate of survey return is supported by the graph? There's a positive association. And I'm sorry, there's nothing in there that relates that. In fact, to show a positive association, I would probably need a scatter plot. So I would either need a scatter plot or some sort of regression graph. This box, this type of graph does not show that. There is a negative association. Once again, we don't know anything about association for the same reason. The number of surveys used in the dining hall method was less than the number used in either of the delivery methods. They didn't tell us anything about the number. We know the proportion, we know the percentages, but we don't know actual numbers. We can't make those comments. The psychology delivery method displays the most symmetric results. This is not the type of graph that symmetry makes sense. All right, this is not a histogram. If it were a histogram, we could do that, but with a segmented bar chart, we can't do that. The in-class delivery method had the greatest rate of return, and yes, it had more than 50%, so 20 is E. All right, and that's that video. Thank you.